Here's the second part of the video I made about how I went crazy and created 3D walls in GameMaker. In this video I'm going to talk about how the lighting works, but you should probably watch the first video as well to understand this one better. Again, this is disappointingly simple, yet it works quite well. First, I'll tell you about the blend modes and specifically the subtract blend mode. Blend modes determine how the result is calculated when you draw a color over another one. So for example, if you had a white rectangle and drew a red circle on it with the subtract blend mode, it would subtract RGB values of the new shape from what's on the screen. So it would be something like leaving us with cyan. We'll use this technique for most of our lighting. We start by creating a surface that is completely white. Then, where the light source is, we draw a circle that is the negative color of the light source. So for example, if you had a red light, we draw a cyan circle. Now if you noticed, this is essentially the negative version of what we want to see on the screen. We have to draw it in the negative color because we'll be using the subtract blend mode. This means that the white area will be subtracted from the screen, meaning it'll be completely black, giving us the shadows. And we use the negative color for the light as well, because if the floor was white and was being lit by red lights, it would look red. We get this red color by subtracting the negative of red, which is cyan, from the floor color.
Brief intermission. You should check out Find Your Wings on Steam.
Now that was the easy part. Now on to the simple part. You probably noticed that the walls are lit in a slightly different way. And they indeed are. Here's how that works. So light gets weaker and weaker as you get farther away from the source, right? Using that logic, we use the distance between the player and the wall. Quick note, in the last video I talked about how the wall textures are drawn with a custom function, which takes the base color and the top color. We'll use these colors to implement the lighting effect. The top color is just black, since it's meant to be unlit. The base color, however, is where we'll input the light color we've calculated. And here's how that one is actually calculated. This may seem complicated, but it's really not. V is the value or brightness of the light color we've set at the start. For example, if the light was white, the value would just be 255. D is the distance between the light and the wall, and R is the radius of the light. This equation simply turns the distance between the wall and the player into a range between 0 and 255. So if the wall is out of the light's range, it'll be black, and if it's right next to it, it'll be at full brightness. We then create a new color using the light color's default hue and saturation, but with our new value. All we've done here is create a new color that is darker than the original color. We then pass this into the drawing function as the base color. And there you go, working like a charm. But this wouldn't be a proper TV video without, something being broken, so it's a bit hard to notice here, but there's a big problem. This overrides the color of the wall, so even if the wall was red and lit by a white light, it would look white because it ignores the color of the wall itself. The solution to this is actually the same as the solution that I showed at the start. We need to get the negative color of this light and subtract that from the color of the pillar. And there, now we can have realistic colored lighting on these walls. Next up, shadows.